Okay. Nitrate contamination is one of the most widespread and severe existing threats to Wisconsin's groundwater and surface water. Nitrate's very water soluble, so it moves with the water cycle from groundwater recharge areas into aquifers and then to surface waters.
Depends which form the nitrogen is in.
Yeah, we'll get to that in a second here. Naturally occurring nitrogen levels in groundwater are generally below 1 part per million, 1 or 2. Levels above that indicate human contribution. Safe drinking water level is 10 parts per million based on long-term consumption by pregnant women. And, well, basically long-term consumption by anyone, and even short-term consumption by infants and pregnant women.
What's the name to give this presentation, please?
Yep. Yep.
Audrey, yeah, she said that natural nitrogen levels occur at 2 parts per million.
Yeah, she uses 2. This is Stephen's point. They use 1. That's why I said 1 to 2, somewhere in there, depending on who you're listening to.
And 1 milligram per liter.
Right. Okay. Do I need to do something?
People online are not seeing this for some reason.
We've got it now.
Okay, thank you.
Okay. A 2014 report summarized studies suggesting links between nitrate ingestion on 33 different effects, including 11 types of cancer, methemoglobinemia, or blue baby disease, which you already heard about from the health department, is a rare and serious disease. And it's the only health effect that is the actual basis for the drinking water standard. Strongest evidence for a relationship between drinking water and nitrate ingestion in these other adverse outcomes, besides methemoglobinemia, is for colorectal cancer, thyroid disease, and neural tube defects. A particularly powerful study funded by the National Cancer Institute involved 22,000 women in Iowa and spanned decades of exposure. It was a cohort study of postmenopausal women, lifestyle, and health outcomes. The cohort study is the best available scientific method for measuring the effects of a suspected risk. The results clearly indicate a significant increase in risk due to consumption of nitrate-containing water and several types of cancer. Many studies have observed increased risk with ingestion of water nitrate levels that were below the regulatory limit. Again, the regulatory limit here is 10, and these risks are associated with consumption of 2.5 to 5. Modern geographic information technology helps to understand the geographic distribution of the problem in groundwater. You saw some maps like this about bacteria. This one is on nitrogen. The orange sections have, and these are geographic sections, have average well concentrations above 10. You add the green and the yellow, and now you've got an indication of those who might be at risk from some of these other effects as well. So that's almost half the state. That's either orange, green, or yellow.
geographic township section is only 4 miles. That's a 6 by 6 on there. Very huge pixel. What, one well in a
So
township?
maybe these are counts. These are averages though, the average of everything they have in each of those pixels. So half would be more and half would be less roughly. There's some costs associated with high nitrate. A third of all residents get their water from private wells. Statewide, 10% of all tested wells exceed the drinking water standard. That goes up to 20 to 30% in intensive ag areas. Municipal water supplies, as of 2012, 47 had raw water with nitrate above the drinking water standard, as opposed to only 14 that had that problem in '99. 74 additional systems have increasing nitrate levels, and there are hundreds of smaller systems that are also forced to treat and mitigate. And by smaller, I think they mean like trailer parks and things that aren't municipalities, but still fall under a public water supply category. And there's some economic impacts associated with that, 32.5 million for those municipal repairs, and we don't have cost estimates on bottled water or working on wells in the private sector.
You could go back to the map for a second. You said the 20 to 30% exceed the water standard in ag-intensive areas, and then you were talking about Browning, Lyon County, and those extensive agriculture areas. So why is the nitrate the lowest level on that area? And that's the lowest on the map, and you said it's a 20 to 30% increase in a high ag area, and that's the lowest reading on that map there. How do you explain that?
I guess I can't offer an explanation for that. Anybody online have some insight into that?
This is Jim Vandenbroek. So you're talking about eastern Wisconsin?
Yeah, there's a lot of ag in eastern Wisconsin, but we don't seem to be showing high nitrate levels in eastern Wisconsin.
Yeah, these are, I believe this is private wells. Tend to take
That's
it from relatively shallow groundwater, and you've got much heavier soils over there. I mean, it is interesting, and they often have, one or two different aquifers that they're pulling water from. And I think it's because of the heavy clay soils on the eastern side of the state that tends to have, be a little bit protective of those wells.
This is Chris. I think the other possible explanation is that because the flow through that fractured bedrock is so fast, that those nitrate levels and the bacteria levels change pretty rapidly. And so it's possible that there may be high nitrate levels at times, but not all the time. Just the same thing we see with the bacteria.
Okay, I'm going to catch up here. We'll talk a little bit about nitrogen impacts on lakes and streams. Nitrate stimulates growth of water plants and algae, a process called eutrophication. Can deplete oxygen, killing fish and other aquatic organisms. It can be toxic to aquatic animals, and it can degrade wetland plant communities. Those two pictures there are two oxbow lakes along Lake Wisconsin. One of them is getting a lot of groundwater nitrate load, and the other one isn't, and it's pretty easy to see which is which. This is along the Wisconsin River. If I said Lake Wisconsin, I'm wrong. Lake Wisconsin is, I meant along the Wisconsin River Valley. In the southern Wisconsin, there are these backwater lakes like this. There are state-threatened fish species in these Wisconsin River oxbow lakes, and they're particularly susceptible to nitrate. Wisconsin doesn't have a standard for nitrates in surface water. Studies have documented these numbers that nitrate below 2 is needed to protect the most sensitive species, and below 3.5 to protect general fish and aquatic life. Notice these numbers are less than the drinking water standard. But surface water numbers typically run less than groundwater numbers, because even when high groundwater comes in, if there's water coming in from the rest of the watershed, it tends to dilute it out. And so streams flowing through areas of high groundwater nitrogen can have lower surface water nitrogen numbers. The nature of surface soils plays a big role in the amount of surface nitrogen that moves through the groundwater. This map compares the distribution of sand soil areas to nitrate levels around the state. And you can see it's not a really good relationship. There are some places in the state where it seems to be related and other places not, because it's just one of the factors. Another factor is the bedrock, the nature of the bedrock. That also influences nitrogen movement. And once again, you can see some relationship, but it doesn't explain the whole thing. Another relationship that's been established is land use. It plays a significant role. As a general rule, as agricultural density increases, so does groundwater nitrate. But we pointed out that one example on the map where it didn't. So it's just one of the factors: land use, soil type, bedrock. It all interplays together. And here's just a shot of the agricultural land use and nitrate. A little different map than before. Some relationship, but not super. And this is an indication of where Stevens Point estimates nitrogen comes from, that gets into the groundwater, at least the human portion of it. Most of it comes from agriculture. Septic systems. The orange is septic systems. Septic systems are not designed to remove nitrogen and are also a source. Studies at UW-Stevens Point have estimated that residential subdivision with a density of 0.6 acre lot releases the same amount of nitrogen to the groundwater as a cornfield in a well-drained silt loam soil.
How big is a cornfield?
Whatever the size, you put 0.6 acre density in the same spot, and it's same amount of, in that soil type, same amount of nitrogen. 0.6 acre densities, which is a pretty dense subdivision. Anytime nitrogen fertilizer in any form is applied to the land, some is lost to the groundwater in the form of nitrate. This gets to the question about forms. There's conversions that happen. Some is lost to the air. Some of it stays for a while in organic form. So there's a lot that goes on with nitrogen. But by the time it makes it into the groundwater, it's usually been converted to nitrate.
I have to disagree with you. You said anytime you put nitrogen fertilizer on, some of it gets to the groundwater. Nobody can make a statement like that. If the crop utilizes it and it's tied to a source like a carbon source, or releases slowly like the earth, which is the safest way to apply nitrogen. That's a false statement.
I will make note of that.
You said, these three words, anytime you apply nitrogen fertilizer, some of it gets in the groundwater. That's what you said.
Which means, so you would maintain there are some places where 100% never moves.
Yes, if you utilize like it's supposed to. Absolutely.
Well, okay, apparently we got some.
Say all the time or,
Yeah.
or forever.
I hear you. Maybe we better not say that.
Change it to 99%.
Yeah, I don't know if anybody else out there wants to comment on that.
Well, you haven't mentioned, you're wanting to get a turn it over to Mr. Cole?
I don't think I'm gonna get one.
Okay.
Okay, I think I'm gonna move on. Nitrate can move through groundwater in zones. In this example, nitrate from the farm well is affecting only the deeper well. The shallow well is not affected by the farm field, but could be affected by the septic system of the upgradient residence. It's important to recognize that deeper isn't always better. Nitrogen use as a fertilizer has increased drastically from the 1960s to the 90s and has since somewhat plateaued. Nitrogen levels in Wisconsin streams show the same trend. In this one, the size of the circle is the concentration, and you could see that even a high concentration is 3 to 6 in surface water, and the color is whether it's going up or down. So orange means it's going up, blue means it's going down, and the size of the circle is how much it is. So there is no standard for Wisconsin streams, but it looks like if we did do one, it would be somewhere like in that 2 to 4 range, and a lot of the state is in that range. We're going to talk a little bit about nutrient management plans and nitrogen. Although agricultural nitrogen application rates for all farms are required to be managed, it can't be enforced on all of them. There's the 37%, you saw that. Nutrient management determines the point at which adding more nitrogen no longer is beneficial for a given crop or agricultural purposes. Applications beyond this point have been shown to dramatically increase losses of nitrogen to groundwater.
I would like to make a statement about even on there, adding nitrogen as diminishing increases to crop yield. While that may be true on certain crops, maybe rye and small grains, that's a pretty big stretch on corn. I mean, you can get 540 bushels of corn in Georgia. So, there's a point of diminishing return economically where it's just not economical to put any more nitrogen on or fertilizer on because you're just not going to get any more yield out of it. And that's what farmers use when they're deciding on their nitrogen fertilizer, their phosphorus, their potassium. It's the point of diminishing return. If this field can only pull 130 bushels of corn, that's all it gets fertilized for because it's just a waste of money after that. You're not going to get more corn off of it. Maybe in a super good year, but average year, no. So.
Well, that was kind of the point we were trying to make with this slide. So if it's not making it, I guess we could fix the slide. We basically wanted to point that out. You get to a point of diminishing returns. So we can work on the slide. That's what we're trying to say. And also it considers that some crops need more nitrogen than others. This is just one example in one setting of nutrient management. This particular one, there's 50% more nitrogen recommended for corn on irrigated sandy soils versus loamy soils. Sandy soils allow a large portion of nitrogen to leach below the root zone, and then it gets into the groundwater. And the impact of nitrogen loading on the groundwater really isn't part of the guidelines. I mean, that's not specifically in there.
Me too. Where did that 50% come from?
This was an example site.
So irrigated fields, if you take a non-irrigated sand field versus an irrigated sand field, the limiting factor when you're growing any crop on sand is water. So what farmers do when they are irrigating a crop, corn specifically, which needs nitrogen, is they put a little on at the beginning of the year, they come back, they side dress a little with a nitrogen inhibitor, and then they take a basket, they have a pump, and it prevents back siphoning, and then they spin nitrogen on with the water through the year. So instead of putting big, massive amounts of nitrogen on, they put it on a little bit at a time, so the crop can use it a little bit at a time, because
Well, it's a good example of an optional best management practice. It's not required by law, but it's a good management practice.
Nitrogen cycle is a very complicated deal, and you've got to be a soil scientist to actually understand it. I only know little bits of it. Organic guys aren't allowed to put any commercial nitrogen on their soil to grow their crops. The soil makes it. The bacteria life in the soil makes the nitrogen by breaking down the mineralizing, that's the right word, you know, in the soil. So I'm confused about that 50% more.
Okay. Well, you know, this is our first attempt at this, and maybe this slide isn't a very good way to convey the message. And like that other one, we can certainly work on that.
Paul?
Comment.
Would it be possible that they're saying that we have no irrigation on sand soil? Because 90% today.
Paul?
If you irrigate it, you might get 150 to 160, which would increase the amount of nitrogen that you have to put on the crop because of production.
I would agree with that.
I think that's what this slide is saying.
Chris, were you trying to say something?
I was trying to say that that figure comes from the University of Wisconsin Extension recommendations. So if you look at the chart that tells you how much you're supposed to apply, that's where that number comes from.
Okay, well, I think we're going to have to move on. We can't spend too much more time on this one slide. Well, I've noted that we'll work on that slide. The performance standards in NR 151, which applies to all farms, and requirements of NR 243, which applies to CAFOs, states that the discharge of nutrients will be limited for the purpose of complying with surface and groundwater standards. Those are the exact clauses from those documents. However, while the law expects agriculture to conceptually meet groundwater standards, NRCS 590, which is the basis for this process, contains this disclaimer. Policies often view university recommendations as a vehicle for achieving environmental objectives, while the basis for developing the recommendations are agronomic. So we're kind of left with a challenge here. The current Wisconsin standards and cropping guidelines are supposed to protect water quality, but and the practices related to timing and placement of nutrients as well as the source, they do provide some protection to groundwater and surface water. The amount or quantity applied is determined by optimizing expected cost of fertilizer versus expected crop yield. And we don't have a tool for estimating nitrogen loss to groundwater similar to what we have for phosphorus.
So, estimating nitrogen loss. So, the way nitrogen, phosphorus and nitrogen are totally different in the soil. So, to get the point where you can estimate nitrogen losses to the soil, you would in essence need a weather station in every field, because temperature and moisture make a big difference on how much nitrogen you use, even with a nitrogen indicator, which keeps it from going from positive to negative. So they have some out there. I think like Yield 360, there's some out there, and they're really complicated algorithms, and they'll only do the field because of.
Well, the conversations we've had with some of the researchers on this think it might be possible. So we'll see. I mean, if you have to have a weather station at each field, it ain't going to work. They'd have to come up with a way to do it without that. The results of some studies I'd like to share with you. That significant groundwater problems have been associated with applying nutrients above the recommended level. But there's also some places where even where nutrient management plans were followed, nitrate groundwater concentrations exceeded the standards by a factor of 2 to 7. Now, those were some bad spots, admittedly. And just an acknowledgement that additional protections like those recently added for Silurian dolomite are sometimes necessary to protect groundwater. We're getting to some conclusions now. Fertilizer application has resulted in 20 to 30% of private wells in intensive crop areas exceeding the standard. There are health concerns even with nitrate levels below 10. Current nutrient management plans are likely insufficient for groundwater protection when growing crops needing high nitrogen in settings where loss to groundwater is rapid. The current agricultural economic and regulatory systems differs environmental costs from agricultural producers and consumers to the owners of the water supplies. I mean, the people who are fixing their wells. And the current system has no basis for determining compliance of farms with groundwater standards. So some recommendations, once again, widespread use of nutrient management plans. Acknowledge that in some cases, even using nutrient management plans probably won't protect groundwater. And more widespread private well testing. Some recommendations at the state level, try to get that nitrogen loss estimator to groundwater working, a speedometer for nitrogen. Challenge the scientists to do that. Monitor the effect of alternative practices on groundwater nitrate at representative areas. That practice you were describing and stuff that Discovery Farms is doing is working on this to try to keep more of that nitrogen in the field. Some more epidemiological studies on nitrate in groundwater, and a surface water standard for nitrogen, which we don't have. And that's what we have. Any other questions that you didn't already ask?
Is there an accurate, simple test to show the presence of nitrate? Not necessarily an accurate level, but you better get your ass in and get some real testing done. Kind of a test that can be done.
Are you talking in drinking water?
Yeah, because residential people, we've been trying to get them to get out and get their water tested. I've got a list of about 40 people that I follow. They don't do it. The only way you're going to get the test off that well is if they're well equipped and the pump installer fixes it, or if you go to their house and sample it for them, sit down and have coffee. And
Well, Chris, did you hear that question? That's sort of.
Is there like a test tape they can dip in there, something to put in the mailbox to send to them?
Chris, did you hear that question?
I did, and that's a good question. I know we have some little handheld field devices that we use, but I don't know of something that you can buy in the hardware store or anything like that. Jimmy, do you have any idea?
No, I think the easiest way, and it's a simple test from State Lab of Hygiene. They're pretty inexpensive, and homeowners can ask for the kit. They don't have to share the information; they can just get it. And Chris, the right there in Stevens Point, there, counties have engaged the Center for Groundwater Studies or Watershed Studies to do regional sampling programs. So there are ways to get this done, and it isn't very expensive.
Well, Eau Claire County has its own lab, is that right?
Yes.
Okay. So perhaps then they don't participate in those programs that Jim was talking about, but there are programs offered through UW Extension at UW Stevens Point where they will do, offer sampling that's convenient for people to come in on a certain date, drop off their samples, and then there's an education program that comes with that about a month later. So sometimes that increases participation if it is something that seems to be endorsed by some local group and seems to be, what everyone's doing in the neighborhood